In today's lesson, we're going to review how to factor binomials, factor difference of two squares, and factor some basic trinomials. These first four problems that we're going to look at are all binomials where the terms have something in common. You're going to use the process of GCF, greatest common factor, and you're going to ask yourself, what is the largest number and/or variable that can divide into both of these terms? So in number 1, I first am going to look at the numbers, 2 and 6. What is the largest number that can divide into both 2 and 6? 2. When it comes to variables, sometimes people get confused about what the largest that can divide into both of them is. If you have an x squared and you have an x, if you will look at their exponents, you're going to choose the smallest exponent out of the terms. That's what they have in common. After you've written down what can divide into both of these terms, I want you to put a parenthesis beside it. This parenthesis is going to hold what's left over when I divide 2x out of these two terms. When I divide 2x squared by 2x, the only thing that is left is an x. So I'm going to write that down. Since both of these terms are positive, a positive 6 divided by a positive 2, I'm going to go ahead and write the positive sign down also. 2 divides into 6 3 times. And when the variables divide evenly, it is a 1, but 3 times 1 is still just 3. You can always check your work by distributing your 2x to see if you get the original problem. If you do, you've done this correctly. On number 2, what do these have in common? I can divide a 5 into both of them, and they both have at least a v squared. Remember, choose the smaller of your exponents. When I put down the parentheses to hold the leftovers and I divide the 5v squared out of each term, I am left with v plus 10. I can distribute my 5v squared to check my answer, and I've done it correctly. On number 3, what do they have in common? The largest number that can divide into both of them is a 4. And the largest variable that shows up in both terms is an n squared. Once I divide 4n squared out of each of my terms, I am left with n minus 6. Number 4. What do they have in common? They both have a 2 and a p. When I divide 2p out of each term, I am left with p minus 3. All right, the next type of problem that we're going to talk about is difference of two squares. 5 through 8 are all binomials. They have two terms, but these terms do not have anything in common. If you look closely at the numbers that are involved, every single one of them, the numbers and the variables, are all perfect squares. So just to kind of remind you, your perfect squares: 4 is a perfect square, 9, 16, 25, and so forth. In difference of two squares, and notice I used that word difference. Difference means that you are seeing subtraction in every single one of these problems. In difference of two squares, you will factor by putting down 2 parentheses. In order to factor, you're going to split your square between each parentheses. If I asked you what is being squared to give you x squared, you would say x times x. You would do the same thing for the number 9. What number am I squaring to get 9? 3 times 3. In difference of two squares, the signs in the parentheses will always be the opposite. So one parentheses will get a plus and the other will get a minus. Now notice, we've been talking about conjugates. These are conjugates. So when you check, instead of doing all 4 steps of FOIL, you only need to do first and last. So if I multiply x times x, I do get x squared. And when I multiply 3 times negative 3, I do get negative 9. Let's try these 3. On number 6, remember, both of these are perfect squares, and it is a difference of 2 squares. What am I squaring to get x squared? X times x. What number did I square to get 36? 6 times 6. One parentheses gets a plus sign, the other gets a minus. In number 7, what am I squaring to get x squared? X times x. What number did I square to get 100? 10 times 10. One parentheses gets a plus, the other gets a minus. On number 8, you know it's the difference of 2 squares, but a lot of times people forget that 1 fits into many categories. It's a perfect square. It's also a perfect cube. It's even perfect when it comes to being raised to the 4th power and so forth. When I split 1 or ask you what number is being squared to give you a 1, it's just itself. So the answer to number 8 is x plus 1 and x minus 1. These last 4 problems all deal with trinomials. When you factor a trinomial, it will always split into 2 parentheses. I'm going to give you a couple good things to remember as far as the signs are concerned. If you are factoring a trinomial that ends in a negative number, then you automatically know you're going to have a positive times a negative. The numbers that you put in your parentheses will have opposite signs. And here's why. In order for a trinomial to factor properly, you have to think of 2 numbers that can multiply to the end number that will also add to the middle number. Multiply to the end, and in this case, a negative. The only thing that can multiply to a negative would be opposite signs. So things that multiply to 27. You may already know what the answer is, but I'm going to run down a couple of these. It could be 1 times 27. It could be 3 times 9. We're looking for 2 numbers that can multiply to a negative 27, but when I combine them, I get positive 6. 3 and 9 are going to be a good choice. I need to figure out which one gets the positive and which one gets the negative. When they have opposite signs, the larger term is always going to match the sign of the middle. So if I put the positive with the 9 and the negative with the 3, and I add those 2 numbers together, positive 9 and negative 3 does indeed give me positive 6. In number 10, we're going to follow this same process. The a squared breaks down into a times a, and I need to think of 2 numbers that can multiply to a positive 56 that can add to a negative 15. When they multiply to a positive, I know they're going to be the same sign. They're either both going to be positive or they're both going to be negative. So here's where you need to look. If the middle number is negative, then both of my signs are going to be negative. Numbers that can multiply to 56. 1 times 56, I think those are too large. 2 times 28, still too big. 3 won't go into 56, so I'm going to skip over that. 4 will go into 56 14 times. Still not what I'm looking for. How about 7 and 8? I need two numbers that can multiply to give me a positive 56, but when I add them together, they will give me a negative 15. 7 and 8. All right, number 11 and number 12. Following this same process, on number 11, the x squared breaks down into x times x. My final number is a positive number. So when I'm looking for two things that multiply to a positive, I know they have the same sign, and they're going to have the same sign as the middle term. So both of these are going to be negative. I need two numbers that multiply to 48 that will add to 14. So I'm going to think through some of my possibilities. I've got 1 and 48. That doesn't add to 14. 2 and 24, not going to add to 14 either. 3 and 16, nope, not going to work. 4 and 12, still not working. How about 6 and 8? 6 times 8 gives me 48. But when I add a negative 6 and a negative 8, I do get negative 14. So that works. All right, number 12, just so you can see it one more time. 2 parentheses. The a squared breaks down into a times a. I'm looking for two numbers that multiply to a negative 6. There's that negative sign. Means that they're going to be opposite signs. It really doesn't matter which parentheses you put the sign in, but we do have to be careful about what number we put in each of these places. They're going to multiply to a negative 6, but when I put them together, they're going to add up to a negative 1. So let's think about this. I don't have a lot of possibilities in 6. I have 1 and 6 and 2 and 3. When I put opposite signs, it actually causes these numbers to subtract. So which group would subtract and give me a negative 1? It's going to be this 2 and 3. Now remember what I said earlier. If you're trying to figure out which sign goes with which number, you can just try them in the different blanks, or you can remember that the larger number is always going to match the middle term. So negative 3 and positive 2 does give me negative 1.